And I'm going to be switching back and forth a little bit between Zoom's whiteboard and our programming tools. So I think at this point, we're going to start off with the programming tools before I get heavy into the lecture on programming itself. That way, folks have a little bit of a chance to make sure their system is working and can get into it and operate. So from those unzipped files that you have, we are going to launch the apps tool. Pretty simple window, pretty small. The first step that we are going to follow for this, and we do want to follow these steps very specifically. You may have gotten a pop-up when we launch the app tool about if it's okay for firewall access, if it's okay to run the program, things like that. Our answer is yes in this case. We do at least somewhat trust the provider of the program. So first thing we're going to do is we're going to hit the create button. This will allow us to create our virtual controller. Okay, we're going to call it whatever we want. I usually call them virtual as a start, just for a reference point for me. And in this case, I'm going to be creating a BAV controller for best day 2. Okay, that's going to be my name. Next thing I have to do is I have to select an SVM version. Okay, and I think I have to change how I'm sharing my screen. There we go. Okay. Now remember that this programming tool is specific to EasyIO calls. So each different version of this SVM, by the way, stands for Sedona Virtual Machine. Okay. It's going to be something akin to the firmware version on a specific controller. Okay. For us today, we are going to be working with an FW controller. For those who are working with the FW08-V controllers from EasyIO, this is going to be the same version that you're using. So that's why we're doing it this way today.
Robert, I need to interrupt. I'm sorry.
No, go for it, Jenny.
I clicked on the apps tool. It says no apps folder found in the selected directory.
Gotcha. So you need to go back to the Google Drive and download the apps tool fixed version.
Okay, that's what I unzipped.
Okay, so
yeah,
we'll address that one then. Hang loose for just a second and we'll get into how to fix that if you run into that issue.
Thank you.
Absolutely. So for today, I'm going to choose this latest firmware version of the FW controllers. So all the way at the bottom of the list. I'm just going to hit the create button. Okay.
Quick
Now
question,
I'm going
Robert. I might have missed it, but did you say we cannot leave a space between names? Do we have to put the underline there or not?
No, you can use spaces in this. I don't from old programming habits.
Okay,
so
thanks.
Spaces are just fine here. Okay. I'm going to close out of the apps tool here for just a moment to answer Jenny's question, and in case any of you run into the issue as well. So in the program, or in the folder where you unzipped apps tool, go into the apps tool folder. You're going to go into the Sedona folder, and you're just going to right click, new folder, and name it apps, APPS. This needs to be done with the apps tool shut down.
Okay.
Okay. And you don't have to put anything in the folder, all lowercase letters. That's all you have to do. It's
okay.
Just whatever reason the version that they sent wasn't fully set up. Don't ask me why. I have no freaking idea.
I think I might have done this earlier, but thanks again. Now I'm just waiting for a file folder to transfer, but I'll catch up.
Okay. If you need help later, just give me a shout.
Thank you.
So I'm going to relaunch my apps tool now that we can see it again. To start, what we've done so far is we've created the files for that virtual controller. Now we have to start it. So we're going to come in to hit the application options drop-down menu, and we're going to select that virtual controller we just created. And then we're going to hit start. Okay. And it's going to barf out about 10 lines of information here. The most important one for us is this bottom line here that says message sys app running. If it says that, you are good to go. Okay.
It did give me correct rights to my computer. 'Cause it-
Okay. Everybody up to speed to that point? Or more or less up to speed at least? Okay. Next up, we're going to jump into our CPT dev old folder. Remember, if you downloaded the CPT dev do not use version, this is probably going to work terribly for you. And by work terribly, I mean it's not going to work. And we're going to launch CPT. And if it pops up with an error saying that it doesn't have access to certain folders or something like that, you've probably accidentally gone into your the not unzipped file folder. Okay. So this is what it's going to look like when you first connect. We have a Sedona app. We can change the app description. I'm going to change mine to virtual VAV because it's descriptive. It means something to me. Change it so that it means something to you. The other thing we have to change is we have to change our host address. So if we were connecting to a real controller, which you will be doing later or tomorrow, then you would put your host IP address here. And for a FW controller, it's 192.168.10.30. That's the default at least. And you can find that in the documentation. But for today, we're going to change it to local host. All one word, all lowercase. We don't need to change our port numbers. That's the Sedona port number. Admin is the proper username. Leave password blank. The only other thing we have to change is our data folder. And the reason we have to change our data folder is because we are not connecting to a Sedona or an EasyIO FG, G as in good controller. We're connecting to an FW controller, W as in wireless. Okay. Once you have those all set up, change to local host, FW drive or data folder, and whatever you want to call your controller, hit save. Then you don't have to re-enter the data later, and hit open. It's going to ask you for a password. Password on EasyIO controllers by default is blank. That's for all of their controllers. So just hit OK. And after a moment, it should pop you into the programming tool. Okay. I'm going to switch over to whiteboard now, and we will come back to the programming tool. So if you're still chugging along with that, don't worry. We're not using it right away. We're going to talk about a couple of things, then come back to it.
Hey, I got a quick question.
Go for it.
Is the other app tool supposed to be closed or open?
The other app tool must remain open. You can minimize it in the background or just let it fall to the back on your windows, but it does need to be open. Other questions at this point? Okay. Well, if you come up with them, toss them into the chat or shout them out. So the first thing we have to talk about here, and everybody should be able to see the whiteboard, right? First thing we're going to talk about is data types. Okay. Every programming language has defined data types. This is specifically what kind of information that programming system is capable of handling. Okay. For Sedona specifically, we have 3 primary data types. There are a number of others in the background, but we don't interact with them, at least not on a regular basis until you start doing some really weird stuff. So we're going to focus on the primary 3. And our first data type is Boolean. Okay. Anybody familiar with the term Boolean? Maybe heard Boolean algebra or Boolean logic.
I think I use those for making soup.
Nice, Ted. Boolean, good stuff, but no. Boolean data is simply 2 states. It is often referred to as discrete data or binary data or digital data, but it is 2 states, on or off. I'm afraid I don't get the reference, Bob. Kernel mapping?
So kernel mapping is the cancellation procedure of like a quick hand, how you can make digital decisions by creating this map and canceling each other out. So
Okay.
it's a piece from within digital logic.
Fair enough. Thank you, Bob. So flowcharts will frequently use Boolean type thinking, this or that. Frequently, we will represent Boolean data as on off or true false, or as a 1 or a 0, okay, depending on what system we are working with. For the most part, we will talk today about Boolean data in a true false format. Our next data type, which everybody should know the name of and be afraid that we're going to talk about math, which we absolutely will be talking about math, so is integers. Integer data is, of course, a whole number. Okay. So it's as simple as that. If we're talking about a number without a decimal, now be careful, just because it may have a 0.00, in our brain, we may be thinking an integer, but it's probably our next data type. And that is a,
Robert, can you speak to just the use of integers? I mean, as a standard that you had to deal with, or you saw mostly, like just basic temperatures or something like that, just to stop the data from pushing across the network or something?
Yeah. I'll be perfectly honest. I don't use integers hardly at all.
I don't see why anybody would. I never got that. Unless it's like way more data, I just don't get it.
And if you get into the infinitesimal scale on data, yes, an integer is half the size or less of our next data type, which is called float. If I can spell.
Then that makes total sense for trends then. Okay.
Right.
Well, what if
So
you had
from-
like a 3-stage piece of equipment and you had to take 1, 2, or 3 as stage 1, 2, or 3 compressors, not 1.3?
Exactly,
You
that
have to see
is,
that that one and nothing else.
Andy, that is an excellent example of times when we might use a integer value. One of the other times that we will be using it for is when we're talking about times. Because when we're talking about time, we very frequently want to talk about seconds or milliseconds. And we don't want to get into decimal versions of either of those. That starts to get a little bit ugly. So there will be times specifically for us for configuration parameters where it must be an integer data type. But to be honest, of the 3 data types we're talking about, integers are the one we are going to use the least often in this workshop. Okay, we'll use Boolean a lot, we'll use float a lot. And what a float data type is a number with a decimal. Okay, and if you get technical with it, both integers and floats have a certain numeric maximum value, but these values are so high that for us, we're never going to run into them. So for all intents and purposes, integers and floats go from positive to negative infinity. And floats have more decimal places than anybody in controls programming will ever come close to caring about. In real programming, we're talking like 32 decimal points. And on the left side of the decimal, a very similar number. In the 18 years that I've been doing controls programming, I have run into one time when a system that ran into an issue with its data type. And oddly, it was specifically a Johnson Controls Metasys system. And it was related to a schedule because this school district ran into an issue where every, I think it was like 48 days, the schedule for the whole system would just totally crash and they'd have to reset it. And it related to, for whatever reason, the system was counting seconds cumulatively. And eventually it got to so many seconds. And if you calculated it, it was 48 days and a certain number of hours. When it clicked over, and it would actually overflow the stack. The data, it had counted so many seconds that the data type for the object that was counting crashed because it couldn't count, it couldn't add one more second into it. So that's the only time I've ever run into data overflow issues in a control system. Except when I did something really stupid. Anyway, that's beside the point. Okay, but those are the 3 data types we are going to work with. They're pretty straightforward, pretty simple. They are not super complex. Okay, everybody okay so far? All right. Now, I said before that we were going to talk about analog versus digital, which fits into our data type conversation. So if we had to put these 3 data types, if we had to categorize them as digital or analog, which would be digital and which would be analog?
Ted knows this one.
Boolean is, actually, Boolean would be definitely digital.
Absolutely right.
And a float would be analog.
Correct.
And an integer
could be both. Depends
Yeah,
on,
it could be either or.
depends on how you want
It's
to count
not, it's
digitally.
not true analog though, and it's not true digital.
It definitely isn't digital. And it is much closer to an analog value.
Right.
So if we're trying to categorize, if we think about this more weirdly from the audio file standpoint, digital, you know, the CDs, the cassette tapes, things like that, that have stored on and off values to be sent to a speaker, in comparison to the waveforms created by a record player, okay? A true analog source where we have variation. So digital, Boolean, just on-off type values. Analog values,
So it's digital.
anything in a range of values. It doesn't necessarily have to have a decimal point to it, because we're looking at a range. A good example of this would be if we're looking at a valve that's between 0 and 100% open, do we really care what the decimal point is in that situation? I know there are some systems that actually would care about it, but for the most part, building automation systems are amazingly forgiving systems for the most part, until you try and do something particularly silly. Okay. So when we talk about analog data or digital data, we're really talking about our data types and just kind of putting a general category around them. Okay. Making sense so far? Okay. I'm going to clear this. Oop. So Michael put in the chat that an integer is more like a step control. And in some cases, yes, it is. That is absolutely correct. It is not. With an integer, there is a definite 1 to 2. Whereas in a true float application, you have an almost infinite number of values between 1 and 2 that you could be at as well. So you are correct. Yes, sir.
So you mean you're saying a counter that is triggered digitally to create an analog wouldn't make it hybrid? Flip flops? Come on, man. TikToks? What do we got? All right, I'm gonna stop. I'm gonna stop.
No, it's good. It was good. All right. So let's talk about some applications for these types of data. And we're going to start off with the simplest type of data, Boolean data, on and off. Really relatable, right? Well, I'm going to do my best to make it not relatable for you. You're welcome. So when we talk about Boolean data, if we need to do something more complex with Boolean data than literally just somebody turned the switch on, we're going to turn the light on. That's really straightforward. We can do that as a one-to-one connection. But what if we have 2 light switches and either of them can turn the light on? Okay. Then we need to get a little bit more complex, and we're going to deal with Boolean logic. Okay. You may or may not need much Boolean logic for the project for this, but Boolean logic is a great place to introduce students to some programming topics and some critical thinking. And it's kind of basic, so we can get into it that way. Okay. And this is going to be one of those points where we're going to switch back and forth between our programming tool and the whiteboard a little bit. So, Boolean logic consists primarily, I shouldn't say primarily, the main tools that we are going to use within Boolean logic are called Boolean operators. And we are specifically going to talk about 4 operators. And anybody who has dealt with Boolean logic will know these by heart already. Anybody who's dealt with electronics will know these already, so they're going to be really familiar. And, or, not, and XOR, or exclusive or. Okay, those are our 4 primary Boolean operators. Okay, like I said, we're going to be switching back and forth between whiteboard and the programming tool. So I'm going to switch over to the programming tool, and we are going to talk about the first Boolean operator, and. Okay. Now, I suppose we probably need to do a quick tour of our programming tool before we can do that. So this, again, remember we are in CPT. So we have our regular file, edit, tools, window type menus up at the top. We have a toolbar. I'm going to point out a couple of very specific and useful tools here on our toolbar. We have our save icons. Keep in mind that most of your building automation systems do not automatically save anything. So when you're doing building automation system programming, save early, save often is my motto. Because if you don't, you can lose a lot of work very quickly. Okay. I used to try and give references to Chicago's old voting schemes, vote early, vote often sayings. But none of my students get that, so I've dropped it. You folks might actually get it, but anyway.
Oh, I got it.
I figured you would. Okay. Other than that, if we come over here, we've got some zoom icons, the little magnifying glasses. Zoom in and zoom out. These will affect our main workspace here in the middle. So we can zoom in, and I will be zoomed in quite a lot for the most part so that you can see a little better. But there'll be times when you'll want to zoom out when you're programming because it will effectively increase your view space. The last one that I want to point out is the left and right arrows up here in the upper left-hand corner, and specifically the back button. This works just like a web page forward and backwards. There will be times, I guarantee everybody will do it at some point, when you'll be looking at an object and you'll accidentally double click on the object and suddenly everything you were working on disappears. Don't worry, you just dove into the object like it was a folder, hit the back button once, and everything should be back to normal. Okay. Now I saw we had some chat comments here. Screenshots from Brad. How do you get rid of the box in the upper right-hand corner? Hang on, let me see what you're looking at.
On your screenshot, Robert, you have a little, it's the wire sheet. It's the small area of the wire sheet. If you click click anywhere in that box right there, and I know there's a way to eliminate that.
Not that I'm aware of.
Okay.
So what Brad is talking about is this little map view. It is the way I refer to it, because the first time I ever saw this was playing real-time strategy games, and you had an overworld map, so you could quickly click on it and zoom to anywhere on the map. So as far as I know, there is not a way to get rid of that. Oops, wrong button. But if you need to quickly move around your worksheet, you can do it that way. Be careful not to drop things onto this map view, because it will drop them exactly wherever you put it on the map. So if you happen to drop it in this bottom left-hand corner, that's where it ends up. So be forewarned. But that's a little bit ahead of ourselves.
And the screenshot that I dropped in chat is in reference to 2 years ago in Omaha, save early, save often.
Very nice. I did see that. I did see that. So, the rest of our tour over here in the top left-hand corner is our navigation tree. This works just like File Explorer. So we've got our different folders. We've got a hierarchy to it. Pretty straightforward. The bottom left corner is going to be the source for almost everything that we do for this project. This is our library. And really, when I do, especially this lecture on Boolean logic and here in a little bit on mathematical operators and things like that, I will draw out basically this view on the board. I'll have a library in the bottom left-hand corner. And when we're done explaining a particular object, I will write it down into the library so that we can use it in the future. Just kind of a visual way for the students to get used to this program, kind of this view of the world. Okay. So when we are in our library, we have a number of different libraries to choose from. And we'll just be dragging and dropping things from the library to our main workspace. Our workspace is called the wire sheet. And as soon as we get more than one object on there, you'll understand why it's called the wire sheet. Okay. Over in the right-hand side, we have our property window. Our property window shows us the properties or the attributes of whatever object we currently clicked on. Right up at the top, it will tell you what library it came from. So this folder came from our sys library. There we go, there's a folder. And it is a folder object. And the only property that our folder object has is a name. Every object in our programming system must have a name. Okay. But that's our property window. Note there is a save button in this bottom right-hand corner. That is specifically for these notes section. It does not save your program, so do not use it thinking it will save your program. Carlos.
Yeah, one of my challenges is these logic blocks. There's so many of them. And before you start lecturing on them, is there a mindset? Is there maybe some memory tips that's going to help you kind of organize it in your brain to help you memorize or know where to find the correct logic block? Because or is it just practice?
It really is just practice. There are some documents that can help. And when we get a little bit further on in this, we are going to talk about some of the documents. But for the most part, it really is just getting used to whatever program system you're working with. And that will apply for the EasyIO Sedona, the Contemporary Controls Sedona, or any other block-based programming language, whether it's ALC or Distech, any of those. It really is just kind of a practice of figuring out where things are and repeatedly finding it, and just unfortunately, effectively, memorization and muscle memory. So I wish I had a shortcut for you. Unfortunately, I don't. So any other questions? Oh, Mike mentioned in the chat that if you go to Tools, you can hide mini view, and that will get rid of that upper right-hand corner view. Thank you, Mike. I have a number of students who are going to be very appreciative of that having gone away. So now, other questions or any questions on the overall layout, anything like that? And just because I didn't mention something doesn't mean it's not important. It just means I didn't think to mention it. So we will probably run into more things that'll crop up later on. But for right now, let's come over to our library and we're going to open our control folder. Oh, I should point out the libraries that are currently installed on this controller or that were currently showing up in this library are the libraries installed on the controller. Okay, there is nothing in here that you cannot use. There are some things you should not use, like things out of the EasyIO CPT folder, for example. But there's nothing there that you can't use. There are some control programming systems that will let you install or drag an object out onto their system and seem like they're using it and then just not work in the field because they don't actually know what that object is. Really annoying. Sedona does not do that. Okay. And these basic, these first four and the bottom one, sys, control, date time, and socks are all libraries that are on every single controller. Okay. Whether they are being shown to you or not, they exist there. Okay. Because these are the basic building blocks that we use to build all of our other libraries on top of. Okay. So the basic functions are there. So right now, we're going to go into our control library. And we're going to come down here to this first AND block. AND, A-N-D, 2. I'm going to click on it. I'm going to drag it out to my wire sheet, and I'm going to drop it. Thank you, Ted. Yes. We will be having a break here in about 20 minutes. So, AND is our first Boolean logic block. Okay. AND is very simple. In this application of AND, we have two inputs. Okay. Two data points that it's going to look at. And please note, currently they're both set to false. That means they are what kind of data? Boolean data. And must have at least two Boolean inputs and will have one Boolean output. Okay. And can have more than two Boolean inputs. It doesn't change its function. You have to be careful how you apply it if you're doing certain things though. But technically you could have an AND block that had 50 Boolean inputs. I would feel sorry for you, but you could do it. Okay. But what AND does is AND says input 1 must be true and input 2 must be true to get a true output. Okay. So I've got my block selected here, and I'm going to change my input 1 and my input 2 both to true, one at a time. I'm going to do that by coming over to the property sheet. And here we've got input 1, currently set to false. I'm going to hit the drop down and set it to true. Okay. Do not use null values here. Null values are a way of saying, I don't know. And it will result typically in the control block saying, well, if you don't know, I don't know. And unfortunately, I don't know has a tendency to break programs. Okay. So right now we've got input 1 set to true. My output is still false. Of course, if I change my other input to true, now my output has turned true. Okay. This will be a trend for the things that we work with. We can change input values, but output values we cannot change. I'm trying to change my output value right now. Notice how it does not allow me to do that. Okay. Many of the blocks that we work with will work exactly that way. Okay. The out value will follow whatever internal logic is programmed into this block. In this case, that logic happens to be AND. Okay. Questions on AND? Okay. We're going to go on to our next Boolean logic block, OR. OR looks very similar to AND, and I'm just scrolling down further in the control library. Most of what we will be working with today is going to live in the control library, by the way. I'm going to drag out or 2 to be specific. And again, that 2 just denotes that I have 2 inputs. Or, like AND, notice they look virtually identical, must have 2 or more Boolean inputs and will have 1 Boolean output. But OR works kind of like the inverse of AND. OR says input 1 can be true, or input 2 can be true, or they both can be true to get a true output. Okay? Pretty straightforward. It does not care if, as long as one of the values, or at least one of the values is true, or says, great, then I'm true. We're going to go. Okay, this is that 2 light switches turned on sort of thing. Being able to turn the light switch on from, or light on from 2 different switches. And would be more like the action movie safe entrance or bomb, enabling the nuclear warhead type situation, where both keys have to be turned to the on position, sort of thing. Okay. And yes, I do use these analogies with students because it kind of helps drive the point home to them, something they can relate to. Our next Boolean object that we're going to talk about is surprisingly really, really powerful, but very simple. It's called not. Not is also referred to as an inverter. So notice we only have 1 input on not, again, Boolean input, and we only have 1 output on not. And the output will always be the opposite of the input. Okay? Always. Really simple, really, really powerful. Most of, or the computers that we are all working on right now, are their main processing in circuits are a combination of not and and, almost exclusively. Those are the most basic building blocks of computers at this time. Okay. I'm going to scroll down to give myself just a little bit of space here for our last Boolean object that we're going to talk about. And that is XOR. Okay. XOR is a special case of OR. What XOR says, XOR can have more than 2 inputs, though usually it doesn't. Most people restrict XOR to having just 2 inputs. Because what XOR says is XOR says input 1 can be true or input 2 can be true, but not both. Okay. So we can have one or the other, but if we turn both of them on, we go back to false. A great real world example of this is 3-way light switches. Okay. At the end of a hall, or both ends of a hallway, or at the top and bottom of a set of stairs. If you turn one switch on, the lights turn on. If you turn both switches on, then the lights turn back off. Okay. We don't frequently use XOR in our programming. It is an occasionally used item. And I made the mistake one time of telling a class, no, you won't use this in the program that we're doing today. And of course, I had a smart aleck student who made it happen, intentionally used it, and made it work very effectively. So. Steve points out that alarms can definitely, or will use XOR at times, and they definitely can. Don't have to, but they can. Okay. Questions on those? Those are our 4 Boolean logic blocks. I'm going to switch over to our, back to the whiteboard if there are no questions. And we're going to look at them another way. Okay. So, has anybody heard the term truth tables?
Yes.
Somebody has. Thank you, Bob. So truth tables are one way to look at Boolean logic. So if we were to look at the truth table for AND with 2 inputs, okay. Okay. Oh yeah, that worked great. Okay. And this is for AND. We plug in the different values that we can possibly have. And for Boolean logic, the number of possibilities will be 2 raised to the power of the number of inputs you have, if you ever need to deal with bigger truth tables. We won't get that far into it. But we start with our default values of false. Oops, I didn't make the table big enough. Okay. Okay. So on an AND truth table, if we have both values inputs as false, our output will be somebody. False. If input 1 is true and input 2 is false, our output is
False.
false. Input 1 is false, input 2 is true.
False.
False. And both inputs are true.
True.
Output is true. Thank you, Hadley. That's a truth table. Really basic. You can look at all of the different inputs for it, or basic Boolean blocks. If you want to get into more complex exercises, you know, with multiple AND blocks or multiple AND and OR blocks and NOT blocks, it can be a really good thought exercise for the students. Just be careful about the number of inputs and blocks you get, because if you're having them do truth tables, it can very quickly become, the truth tables can become absolutely huge unintentionally because of that in or 2 to the n power number of rows that you end up with. So if you have, 5 inputs, that's 2 to the 5th power. And that gets pretty significant because what is that? 32 rows. So you've got to be really careful. Sticking with like 3 or 4 inputs, 5 if you get really wacky with it. But you can add more blocks down line of it to follow through. Okay. Does that make sense to everybody? What questions do you have?
Just a comment. Isn't and used a lot for interlocks?
It
If you have
absolutely is.
True flow, minimum temperature, yada, 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 yada. All those things have to be true before you start up. It's a series of and blocks.
Absolutely. Another way of describing and would be as to compare it to wiring a circuit in series. And or would be wiring a circuit in parallel from an electrical standpoint. So if you've got students who are more familiar with the electrical wiring side, you can describe both of those in that manner. So, thank you, Hadley. Good point. Other questions or comments? All right. Well, that brings us to our first break of the day. A couple minutes early, but I don't think anybody will probably object. We will be back at 10:30 Pacific time. I'm going to take a short break for just a moment, and then I will be back. So if anybody needs any troubleshooting help with getting apps tool or CPT running, we can definitely deal with it here in just a few moments while we're on break. So Melissa. Okay. So last we talked about Boolean logic. Our next topic that we have to talk about is mathematical operators. And when I say mathematical operators, what do you think we're talking about?
Add, subtract, multiply, and divide.
Absolutely right, Brad. Addition, subtraction, multiplication, and division, as well as higher end mathematical operators as well. I was going to go to the board, but I think I'm just going to drop into CPT here. Wow, that was exciting here. No, that's not going to work. So this is the kind of error that you get when you close out of apps tool while you are still connected, or when you try to connect to it again. And there we go. All right, so these are our Boolean blocks from before. I'm just going to move to the side here. We don't need to delete them. We got lots of space. So again, I'm going to drop back into our control folder. And this time I'm going to drag out an add block. And I am not going to beat this horse to death because these blocks work the same basic way, okay, as our Boolean blocks did. For an add block, it is input 1 plus input 2, right? Pretty straightforward there. If input 1 is 10 and input 2 is 2, our output becomes 12, just like we would expect with an add block. Multiplication works exactly the same way, just a different operator. Okay? And with addition and subtraction, they are order independent. It doesn't matter which number is first and which number is second. Now, If you get into subtraction and division, that's when things become dangerous. Same with powers and many other advanced functions. So we'll just look real quick here at subtract. By the way, your basic maths are all in the control library. So subtract, we're going to plug our numbers in the same way, 10 and 2. And with our subtract block, it's just like our add block. It's input 1 minus input 2. So we should get 8 as our output. Okay. So when you're working with subtraction and division, be careful which way you're putting your numbers in. Addition, multiplication, they don't care. Okay. Make sense on that? And you will definitely need some math for this workshop. And I'm going to switch back to our whiteboard so we can look at a couple of really rather important equations for us. Okay. So one of the things that is a basic function of any VAV box is the ability to measure airflow. And for us, our sensors are going to spit out a measurement of differential pressure. By default, it's going to be in inches of water column, which is just great for us because we live in the imperial age. Well, at least from a measurement standpoint. So does anybody know off the top of their head how to calculate CFM, or cubic feet per minute, from differential pressure? What the equation is?
Area.
And it's
Velocity.
typically a multi-step equation.
Velocity, pressure times area. Ooh, yeah. Pressure times area times K factor.
Pressure, or velocity pressure,
Differential pressure.
times,
Velocity.
it's actually velocity
Yep.
times
Area.
cross-sectional area times a K factor or a calibration factor. If you want, you can often get away with labs like this without it, but it is something that you should talk to your students about. Okay, so cross-sectional area, that's easy. That's, you know, if we've got a square duct, length times height. If you've got a round duct, pi r squared. Pretty straightforward. Multiplication. The one question I would offer is, what's an easy way to do a squared number with our programming, do you think? We drag out a multiplication block here, because you'll find we don't actually have a squared function without digging really hard for powers.
Multiply by itself.
Right. So if we have, I'm going to grab a right float, which gives me a number to work with. Let's say we have a, I don't know, 6-inch duct. By the way, if you have to enter a number that is less than 1 in CPT, you must do it as 0 point, whatever the number is. You cannot just put decimal point as the first. It doesn't accept the answer. Okay. So let's say we have a 6-inch duct, which is 25 or 0.25 feet for radius. We'll just take our output and drop it in and connect it to both of our inputs, and we get our squared value. Now, what I did just there was why we call this a wire sheet. I've wired these two blocks together. To do that, grab onto the number of the output, or if you're dealing with Boolean values where it says false, do be careful to grab an out value, not an in value. That one will mess you up all the time. And we're going to drag it, click and drag and drop it over on the words of where we want to connect it to. So I want to drop it to this in one, so I'm going to drop it onto the word, and it connects. If you try and drop it over onto the number, see the no smoking sign, it's not going to let you do it. Always onto the words. And that's one that is well worth driving home into your students' heads. Okay. So when we need to square a value, just multiply it by itself, give it to both references.